Alright, this video will be a little review of basic statistics. I'm talking your mean, your median, your mode. We're also going to be doing the range, variance, standard deviation. We're going to compare two data sets. And last but not least, we will understand how to use our TI-30XS multiview to find the mean and the standard deviation off of a frequency table. Before I do anything else, let me mention to my students, a little personal note to my students, there is a typo on number 5. So these last two values at the bottom of the frequency table should be changed. This 30 should be a 32, and this 34 should be a 36. So, my students, please change those numbers. Thank you. Now, back to the beginning. This list below shows the number of cars sold each month for 1 year by two competing dealers. Here are the numbers. Let's use our TI-30 to find the mean and the median and the standard deviation and the variance. Now, this says show the tables. You should do that as well, but I'm not going to show that in this video. Here's my TI-30. It has stuff in it. I would reset the calculator if I were you. Now, you can reset your calculator by hitting the on button and the clear button at the same time. It should say memory cleared. Hit your data button and we will begin. Let us type in the values for dealer A into list 1 of the TI-30. So we got 8, 9, 15, and so on. There, I've typed all the number of cars sold for dealer A into list 1. Now, I'm supposed to find the mean and the median and the mode. Let's start with the mean. Okay, hit second, data, to get the statistics menu. Hit enter for one variable statistics. I put the information in list 1, so just hit enter until you get to this. So X bar is my mean, so the mean is 17. Write that down. So the mean is 17. How about the median? Oh, yeah, we can find that. Oh, yeah, no problem. Item 9 is the median. The median number of cars sold was 16. Now, how about the mode? The mode, the calculator won't do that for us. Got to use our brains a bit. We're looking for numbers that are repeated. I've got 8, 9, 15. Anything repeated? Alright, 14, okay, there's a couple of 16s. Kabam! So far 16 is winning. 18, 21. Alright, it looks like 16 is the mode. Alright, sometimes my eyes don't see, and I don't want to take too long. But it looks like 16 at a glance to me. Now the range. The range is going to be the highest number minus the lowest number. So at a glance, the highest number appears to be 28, and the lowest number appears to be 8. Okay, I think that's right. So 28 minus 8 is how you would do the range. That's why the range is 20. Now let's skip the variance for a second and go to the standard deviation. Alright, so we're actually going to get the standard deviation first, and then we're going to go back and have the variance. The standard deviation, the symbol for that is a lowercase sigma. Go to item 4 on your list, and this is the population standard deviation. So I see 6.19, etc. Okay, so 6.19. So the standard deviation, lowercase sigma, is 6.19. Now the variance, we can get the variance from that. The variance is the standard deviation squared. Okay, I'm still not very good at that. The standard deviation squared. So I could take this 6.19 and square it. Only thing is, I really do not want to lose these decimals. Sometimes that will throw me off a little bit. So I'm not going to square 6.19. I want to square the whole thing. So this is what you do. Get yourself to a blank area on the calculator. Now, go back to your second data, enter, 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 enter situation. Now, if I go back to item 4, if I hit enter right now, bam! It prints the little standard deviation symbol for me. So if I want to do the standard deviation squared, I can just square it. Okay? It gives me this. It's nice and that's really exact actually. If I want the decimal, I can toggle it. So that is 38.33. Alright? So the variance is 38.33. So understand that we got the standard deviation first, and then we used that to find the variance. Out of curiosity, I want to see how close it is if we do 6.19 and just square that. Alright, it gives us 38.32 if I round it properly. Okay, so it's close, but 38.33 is the correct answer. Yeah, alright, so you may lose a point if you round, if you use the 6.19 for the variance. Anyway, we will just do the exact same thing for dealer B. So go ahead and I like to just reset my calculator real quick, or look, might as well mention this. If I hit my data, if you hit the data button, see how it says clear? L1, if I hit enter right now, it just clears the list. So that's how you do that. So I'm just going to type in dealer B off camera. Here are the values for dealer B that I will be typing in at this time. There, I've just typed in all the dealer B values into list 1. So if I hit second, data for the stat menu, enter for one variable statistics, enter again because I like that it's L1. Okay? So here I have the information. So X bar, that's my mean, is 16. Alright, so that's a little bit less than dealer A. So the mean here is 16 cars. The median, I would have to scroll down to item number 9. The median is 17 cars. The mode, is anything repeating here? 18 is the only value I see repeating. Sometimes I'll miss one, but it looks like the mode is 18. The range, of course, is the maximum value minus the minimum value. So for dealer B, the maximum value appears to be this 27, and the minimum value is 4. Alright, so 27 minus 4 is how we'll find the range. Alright, so that is going to be 23 cars. Variance and standard deviation. We will get the standard deviation first, followed by the variance. So, standard deviation, and then the variance is the standard deviation squared. Standard deviation is item 4 on this calculator. So that is 7.59. Alright, the variance is the standard deviation squared. Now again, I want all of the decimals. So if I were you, I would quit out of this to a blank area. Then I would go back into where we came from. And then I would go to item number 4 and hit enter. That prints standard deviation right on your screen, so you can just square it. And this is the exact variance. But in decimal form would be 57.6 I will round to 2 decimal places. So 57.67. If you guys ever forget how to round properly, you can always hit your mode button, change this float to 2. And now when I go back and hit enter, now it automatically rounds for me, so 57.67. And that's the variance. Okay, so that's the information for dealer B. Now, for number 3, we are supposed to write a summary statement comparing the sales of the two dealers based on the mean and the standard deviation. I'm giving you a hint to write 4 sentences. What I would like you to do is make your 4 sentences sort of like this. I like to do 2 sentences about the mean and 2 sentences about the standard deviation. First, let's start with the mean. State the facts. Who has the higher mean? I see dealer A 17, dealer B 16. So, dealer A has the higher mean. Okay, 17 versus 16. Okay, yep, dealer A has higher mean. So there I've just stated the facts. In the next sentence, you will tell me what that means. So this means that dealer A usually sells more cars. Alright, in that second sentence, you always want to mention what the problem is about. If the problem is about grades, you would say Class A has higher grades. If the problem was about rainfall, you would say City A has more rainfall. So that's your chance to mention what the problem is about. Don't just say dealer A has a higher mean and leave it at that. So these are the 2 sentences about the mean. I'm going to color those red. Now I would like to make 2 sentences about the standard deviation, which I will color blue. Okay, so standard deviation is next. Start with the facts. Who has the higher standard deviation? Okay, I see 7.59 and I see 6.19. So dealer B has the higher standard deviation. So I will just state that fact. Dealer B has the higher standard deviation. And please mention what those numbers are. So 7.59 versus 6.19. Now tell me what it means. This means that, okay, remember, standard deviation reflects variation. So a higher standard deviation means that there's more variation of something. In this case, more variation in the number of cars sold. So this means that dealer B car sales vary more. From month to month. Okay, you didn't have to say the from month to month part, but I think that just makes it a little bit more clear. So this means that dealer B car sales vary more from month to month. Alright, so that's it. That's a perfect answer. That's done. Now, I always like to also say it the other way though. Maybe I'll make this purple because this is sort of optional, I guess. Purple because I went with dealer B and I said how they're higher, and that means that the sales vary more. But I could have also said it from the perspective of the lower one. Okay, so I could have said it this way instead. So this is optional. We're finished, but I could have said dealer A has a lower standard deviation. All right, 6.19 versus 7.59. This means that dealer A car sales are more consistent from month to month. All right? In the second sentence, the sentence of giving the meaning, please make sure that you mention what the problem is about. Okay? Car sales, car sales, car sales. Yeah, do not leave that part out. Notice that a lower standard deviation, we like to use the word consistent, because that means the opposite of variation. Consistent means that the car sales are closer to being the same every month for dealer A with the lower standard deviation. Okay, so that's it for this summary statement and all that. So let's move on to these last two problems. So here's where we work with the TI-30 in order to find the mean and standard deviation from a frequency table. Now look, a little bit of extra information. When they skip like this, it's kind of just a matter of whoever made this table just felt the numbers just wouldn't really fit properly. So that's why they space it out. That's all it is. So you're supposed to use your common sense and imagine the numbers between. So if this is 100 and this is 200, then this would be 150, and this would be 250. Okay, I might have to make this finer. So this would be 350 and 450. Now, the way that you can make a frequency chart on your TI-30 XS multiview is by starting with just the numbers going across the bottom. So go to your calculator. I'm going to reset mine. Just gotta make it clean and easy. Hit your data button. So here I am. Normally I would type in all the data. So the fact that this says 100 down here and this says 70 is the frequency. That means there are 70 100s. 100, 100, 100, 100, 70 times. Now, there's no way we could type that out, so we have to have another technique. Luckily, your TI-30 is up to the job. So, we'll just start by writing one of each. So 100, 150, 200, all the way to 500. Here we go. So 100, 150, 200, 250. Whoa, I missed my 200. 200, 250, 300, 350, 400, 450, 500. Okay? Go ahead and move over to column 2. So you see I've typed in one of each number that you can see across the bottom. Now, to capture the frequency, I will record the frequencies in list 2. So for 100, there's 70 of those. Then it goes 60, 40, 30. So 70, 60, 40, 30. 60, 40, 30. Okay? So this is telling me that 150, well, there's 60 of those. 200, there's 40 of those. 250, there's 30 of those. And keep going. So, okay, we were at the 30. then it jumps back up to 70. So it goes 70, and then it goes back to 30, 40, 60, 70. Okay, 70, and then, so you can see the symmetry. So I know if this is 30, that's 30, 40, 60, 70. By the way, when you have a nice balanced picture like this, we have a middle, and the left side and the right side are symmetric, okay? Then the mean is always going to be that middle number. So guess what? The mean is going to be 300. We know that right now without doing any calculations. So let's just write that down. Okay, so the mean, x bar, we already know that's 300. Now, all we need now is the standard deviation. Okay, this is the symbol for. Let's head back to the calculator. So, here's how you find the standard deviation. Go ahead and hit second data to get to the statistics menu. We will do one variable statistics for a job like this. Now here's where we have to do something different than we normally do. Now we have the data in list 1, but we have frequencies recorded in list 2 this time. So that's what FRQ stands for. So change this, instead of having it be 1, which is what we do when we don't have separate frequencies and we just list every single number separately, we will highlight L2 and hit enter. Alright, that lets your calculator know that all of your data isn't in L1. We need to use the frequencies recorded in L2. Hit enter again. Look how many numbers there were. This N tells us, including the frequencies, how many numbers we're really dealing with. So if we had to type these numbers in a calculator separately, we would have had to type in 470 separate numbers. Obviously that would have been impossible. Well, you know, not impossible, but impractical. X bar, there's our mean. We already knew it was 300, but this confirms it. Now that standard deviation guy. We'll scroll down to item 4. Item 4 is the population standard deviation. And it has 140.29. I'll round it to 9. Okay, so 140.29. Now, for those of you who have a hard time rounding, don't forget that you can hit the mode button and change this from float to 2, for example. That means 2 decimal places. Hit enter. So if I were to go back into that table again, now everything is rounded to 2 decimal places for me. Okay, so 140.29. So that is how you find the standard deviation and the mean from a frequency table. I guess I should say that's the mean. Alright, let's do that one more time and then we will be done. So, again, students from my class, these 2 numbers were wrong at first. So make sure you change these numbers. I think this was a 30, should be a 32. I think this was a 32, it should be a 36. Because in between these numbers, we should be able to use our common sense and figure out what they are. So if this is 20 and this is 24, then this is 22. Alright, and this is 26, 28, 30, 32, 34, 36. And the frequencies as well. This is 10, that corresponds with this right here. Alright, so this must be 15, and then 20, and then back to 15, and then 25, right? And then back to 15, and then 20, and then back to 15. So these are the frequencies that we should be dealing with. Okay, so once again, speeding cars in the school zone. If you're going to make a frequency table, start by listing one of each number, which you'll see here across the bottom. So I'm going to just type in 20, 22, 24, 26, 28, like that. Want to know how to clear a list without resetting your calculator? It's all about the data button. If you hit data, see how it says clear L1? If I just hit enter, L1 is gone. If I want to clear L2, I will hit data, and I will have to choose option 2 to get that done. Alright, anyway, back to listing this. So I'm going to do 20 to 36 by 2s. So it's 20, 22, 24, 26, 28, 30, 32, 34, 36. Alright, is that it? Yeah. Now I'm going to put the frequencies of each one of these. So there's 10 of these, 15 of those, 20 of those. So it goes 10, 15, 20. Okay, so 10, 15, 20. And then it goes 15, 25, 15. So 15, 25, 15. And 20, 15, 10. Alright, make sure your lists end evenly like mine do. So here we have our data in list 1 and the number of times they're repeated, the frequency, in list 2. So hit second, data. Choose one variable, statistics. If you reset your calculator or anything, you will have to make sure that the frequency is not set at 1. Alright, our frequencies are listed in L2, so please make sure L2 is highlighted. Alright, our data is in L1, but our frequencies are in list 2. So just hit enter a couple of times. Kabam! Apparently there were 145 total numbers, but the mean is 28 and the standard deviation is 4.65. Okay, so the mean, alright, so the mean, which is x bar, was 28, and the standard deviation which is lowercase sigma, hard to draw. I already forgot what it was, guys. That's my memory for you. 4.65. And that's how you do it. Now, could we have found the mean without looking on the calculator for it? In this case, yes, because of the perfect balance. We have this middle column here, and then on either side it's reflected. So 15, 15, 20, 20, 15, 15, 10, 10. Perfect balance. When you have perfect balance like that, the mean and the median, for that matter, will always be that middle value. Alright, that's it. I hope this was helpful for you, and I will see you on the next video.